All right, so today we're going to be talking about something called a z-score, in addition to the normal distributions that we talked about in the last section. To start with, we're just going to look at this example here. Suppose there is a normally distributed set of data that has a mean of 25 and a standard deviation of 5. What is the probability that a data value chosen at random is between 23 and 28? Okay, so if we draw out our normal curve, okay, we have a mean of 25, and then each standard deviation is 5 away from that, and so on. Okay, so we would have 30, 35, and 40 on the on the high side, 20, 15, and 10 on the low side. Okay, so in the last section, every time we were asked a question like this, these values fell exactly on one of our standard deviations. What this section is going to talk about is what happens if it doesn't. Okay, so like 23 is approximately right here, and 28 is approximately right here. Okay, so if we are thinking of finding the area underneath the curve for those two sections, how do we calculate that? Okay, we know from the last section when we were talking about the empirical rule, okay, we had this information right here that 34% of the data was one standard deviation above or below the mean. Okay, there was 13.5% between 1 and 2 standard deviations on both sides, 2.35% between 2 and 3 standard deviations, and 0.15% outside of that. Okay, that came from the empirical rule, which we talked about in the last section. But again, what happens if we don't exactly have something within or right on a standard deviation? And that's what we're going to talk about today. That's what these z-scores are going to be about. Okay, so the z-score is given by this formula. Okay, you have your data value minus your mean divided by your standard deviation. Okay, that's going to give us a z-score. Okay, so what we need to do here is we need to find z-scores for both the 23 and the 28. Okay, so let's start with 23. So z is going to be equal to our data value, which was 23, minus the mean, which was 25, divided by the standard deviation, which was 5. Well, that's going to be negative 2 over 5, which is negative 0.4. Okay. The negative is actually kind of irrelevant here because if you think about it, it's a symmetrical curve, right? So whether we are going back 0.4 this way or forward 0.4 this way, that area, okay, underneath that curve should still be the same. I'm going to tell you what to do with this in just a second. Let's calculate the z-score for the 28 as well. So you have your data value 28 minus your mean 25 divided by your standard deviation, which is 5. So now you get 3/5, which equals 0.6. Okay, now what do you do with that? Well, once we have a z-score, the corresponding areas under the normal curve are found using a table. Normally, I would have a nice little handy printout for you, but for some reason my printer isn't working, so I had to write this out by hand, and it's really quite ugly, and I apologize for that. Okay, but this is the table that I'm talking about. All right, you got a lot of z values, you got a lot of numbers in it. Okay, let me explain what's going on. It's kind of broken down. All right, these first two rows. Okay, that's within one standard deviation. Okay, this z-score of 1 means one standard deviation either above or below the mean. A z-score of 2 represents 2 standard deviations, and a z-score of 3 would represent those 3. Okay, so the corresponding a value underneath underneath it tells you the area, or if you were to move the decimal point over, the percentage uh, uh, of the probability underneath that curve. Okay, so again, based on our empirical rule, right, we know that within one standard deviation, you've got 34%. And that's what this says right here. One standard deviation is 34%. Well, how do we calculate, let's say, half of a standard deviation? Well, would that just be 17%? No, it's not, because if you look at the curve, it's not linear, it's a curve. You have more of an area to the left, okay, you've got a bigger area over here than you do over here. So if you use the table, you actually have 19%, that's what this means, within the standard deviation. And then the second half would be, 15% there. Okay, so that's what this table is telling us here. Okay, I'm not expecting you to ever have this memorized, but you do need to probably write it down because you'll need it for your assignment. Okay, so a z, 1/10 of a standard deviation has an area of 4%. So on and so forth. It gets much more specific down here, closer to that 3 standard deviations, because again, the curve is so small at that point. Okay. So anyway, going back to this problem up here, right? We had a z-score of negative 0.4. I told you that the negative doesn't actually matter. So you look at the table here, 0.4 has a percentage of 16. Okay, so we've got 16% from here to here. Okay, so that area represents 16%. 0.6, if you look at the table, gives you a value of 0.3 or 23%. Okay, so because we're on both sides of the mean here, you had to find the area underneath the mean and above the mean, and then you're just going to add those together. So 16 and 23 make 39%. Okay, so that's how we were going to answer this question here. You have to find the z-score for your values that you're finding, and then use your table to find the percentage or the area underneath the curve there. Okay, I'm going to be referring to this table a lot, but let's look at another example again. Okay, the EMT response time for an emergency is the difference between the time and the call is when the call is received and the time the ambulance arrives on scene. Suppose the response times in a given city have a normal distribution with a mean of 6 minutes and a standard deviation of 1.2 minutes. For a randomly received call, estimate the probability of the following response times. Now, it doesn't tell us to draw a normal curve here, okay? So we don't have to. You can if you want to kind of help yourself visually. And so, in fact, I'm actually going to just kind of do that down here, just off to the side a little bit here. Okay, so we have our normal curve. Looks something like that, right? Our mean is 6 minutes. Okay, got your 3 standard deviations on either side. Each one was 1.2 minutes, so you've got 7.2, 8.4, and 9.6. You'd have 4.8, 3.6, and 2.4. Okay, so if we are asked to find the probability of a value less than 5 minutes, okay, so 5 minutes is about right here. All right, we need to find that z-score. Okay, so the z-score would equal our data value 5 minus the mean, which is 6, divided by the standard deviation, 1.2. So negative 1 over 1.2, we want it in terms of a decimal. So negative 0.83. Repeating, our table is only to the nearest tenth, so that's what we want to round to, so negative 0.8. And that kind of makes sense, right? We're almost 1 standard deviation below the mean. We're not quite, so 0.8, that makes sense, right? Okay, so then you go over here and you look at your table. Okay, 0.8 was 0.29. Okay. Now, or 29%. That does not answer the question, however. That only tells you from the mean how far or how much probability you have. Okay, so it's saying that there is a 29% chance in between that data value and the mean. That doesn't tell you less than that. Okay, so we want less than that here. Again, remember, 50% of your data is on either side of the mean. So all you have to do then to figure out this part is subtract 29 from 50. So you get the 21%, which is the correct answer here. Okay, hopefully that makes sense. Between 6 and 7 minutes. Well, we don't need to find a z-score for 6 since that's mean. The z-score would actually be 0. But we do need to find a z-score for 7. Again, that's up here. So the z is equal to 7 minus 6 over 1.2. This is a horrible example because it's giving us the same exact value as the last one. Whoops. Oh well, so we have a z-score of 0.8. Again, looking at our table, 0.8 has a probability of 0.29 or 29%. Now, reading the question again, okay, between 6 and 7, that actually does answer the question. 29% does answer the question, so we don't have to do any math there. Okay, so 29%. Less than 7 minutes. Okay, so now, again, thinking conceptually here, we know that from 6 to 7, it's 29%. But what is it less than 6? Well, again, that's that 50%. Each side of the mean is 50% in a normally distributed set of data. Okay, so all you have to do is do the 50 plus 29 to get 79%. Okay, so hopefully that makes sense. You'll be using a lot more z-scores other than just 0.8. Sorry about that, but hopefully that makes sense. Again, these percentages are from the mean. Okay, so you have to remember that. 34% from the mean is within 1 standard deviation. 43% is within 1.5 standard deviations of the mean. Okay, so use this table a lot if you need to. Write it down, pause the video, whatever, to copy it down. You will need it to do your assignment.